morning. Thanks everyone for waking up for the Fisheries and Ecosystem Management session. We'll go ahead and get started with Krystal Dixon, which is from Cornell University, and we'll be talking about comparing lake sturgeon size at age across water bodies in New York State.
All right, so I'm Krystal Dixon. I'm a student at Cornell University this year, and I'm going to talk about my honors thesis project, which is comparing lake sturgeon growth across water bodies in New York State using size and age comparisons. So a little bit of background: lake sturgeon are long-lived and large-growing fish residing in various water bodies throughout the Great Lakes watershed, and they can live to be over 100 years old. And they were once considered a nuisance fish and are listed for their caviar, which has left them currently listed as a threatened species in New York State. So to introduce the populations that I have data on, populations in Oneida Lake, the Genesee River, and the Niagara River have all been well monitored by various organizations throughout the state. Sturgeon were first stocked and have been stocked in Oneida Lake since 1995, while they have been stocked in the Genesee River since 2003, but they have never been stocked in the Niagara River. So our goals for this project were that we were hoping to understand the variation in stock populations, such as those in the Genesee River and Oneida Lake. We were hoping to understand how these stock populations compare to an extant population in the Niagara River. And finally, we were hoping to set expectations, especially in these populations that are not well studied. So to go into a bit of further background on the data that I have, the Cornell Biological Field Station has an extensive data collection of sturgeon that have been caught in Oneida Lake during their annual sturgeon survey taking place in May and June. And during the survey, sturgeon are caught in mesh gill nets, and once caught in the survey, sturgeon are checked for tags, or if they don't have a tag, they are aged with their spine. And similarly, the U.S. Geological Survey has a data collection of sturgeon that have been caught in the Genesee River during their annual sturgeon survey taking place between May and September. And also in the survey, sturgeon are caught in mesh gill nets, but these nets tend to target smaller and younger fish. And sturgeon in this survey are aged through their missing scutes. And finally, I have data for fish in the Niagara River, which has been monitored by the U.S. Fish and Wildlife Service in their annual sturgeon survey. And this survey is just a little bit different because of the use of overnight set lines, which are trot lines that sit on the bottom of the river. And sturgeon in this survey are aged through their spines. So since I have quite a few different aging methods in these data sets, I thought I'd just recap them. So some of the Oneida sturgeon are aged with their tags if they have one, which is nice because these tags can tell you the exact age of the fish. Most of the Genesee sturgeon are aged through their missing scutes, in which these missing scutes correspond to the year class of the fish and which was stocked in the river. And finally, all of the Niagara River fish and some of the Oneida fish are aged through their spines, in which multiple agers count the rings on the spine until they agree on an age. So what is a size and age comparison? It can be used to compare the average sturgeon length at a certain age in one population to another. And for lake sturgeon, we chose to compare the length of fish at age 6 and at age 9 between populations because these ages are on the rising growth curve. And to do this, we first combined the Oneida tagged age and the spine age sturgeon at age 6 and at age 9 because at these ages, there was no significant difference in the mean length between the aging methods. And then we compared the mean length of the Oneida, Genesee, and Niagara sturgeon at age 6 and at age 9 using an ANOVA test to do this. And then to find out where the specific pairwise differences were, we used a Dixon test. So this graph is going to show the population versus length at age 6, where the x-axis represents each of the populations and the y-axis is representing the length of fish at age 6. And after doing our ANOVA test, we found there to be a significant difference between the means of the populations. So a Tukey test was able to reveal a significant difference between all pairwise comparisons. And just to go into a little bit further detail, the mean Niagara River sturgeon length was 241 millimeters larger than the Genesee River sturgeon. The mean Oneida Lake sturgeon length was 312 millimeters larger than the Genesee River sturgeon. And the mean Oneida Lake sturgeon length was 71 millimeters larger than the Niagara River sturgeon. And once again, we have the same sort of graph, but with population versus length at age 9. And this time, our ANOVA test also found a significant difference between the means, but our Tukey test was able to reveal a significant difference between the means of the Genesee and Niagara populations, and between the means of the Oneida and Genesee populations, but there was no significant difference between the Niagara and Oneida populations at this age. And once again, the mean Niagara River sturgeon length was 313 millimeters larger than the Genesee River sturgeon. The mean Oneida Lake sturgeon length was 334 millimeters larger than the Genesee River sturgeon, and the mean Niagara River and Oneida Lake sturgeon length were not significantly different at this age. So then we ran a linear regression model of age and length and plotted it against the data that we had, where this linear regression model assumes a second-degree polynomial, and it has been restricted to ages where we had sufficient data. So for the Genesee population, this was age 13, and this was age 21 for both the Niagara and Oneida populations. And from these models, you can see the Oneida and Oneida models are looking quite similar, with the Genesee models looking lower than those two populations. So just to recap my main results, the Niagara and Oneida populations are larger than the Genesee population at age 6 and at age 9. And while sturgeon appear to be the same size at age 9 between the Niagara and Oneida populations, there is a difference at age 6. So why is there this age 6 difference? The Oneida sturgeon catching here is best for catching fish age 9 and older, while the Niagara trout lines might be more successful at catching younger fish. However, another possibility does lie in the fact that Oneida Lake might provide conditions that promote larger growth earlier on than in the Niagara River. And this could be because of the physical environment of Oneida Lake, or maybe there's just a lack of competition for these fish. So, at the very least, these differences indicate that any age-length keys created must be specific to each population. And an age-length key is created from a summarization of a small subsample of fish with known ages and lengths, and then this relationship can be applied to the larger sample of fish without known ages but with known lengths. And we use an age-length key to estimate the ages of fish that we don't have, and if this estimate is accurate enough, less time can be spent on handling the fish if only the length is needed in order to age it. So this graph is showing the predicted age and length frequency of the Genesee River sturgeon from the Genesee sturgeon key. The x-axis represents the total length of the fish, while the colors represent the age of the fish, and the y-axis represents the frequency at which this age is predicted given a length. So the younger fish start over in purple, and it shifts over into older fish in red. And from this graph, there's just a big skew to the left where lots of shorter and younger fish are being predicted. And then this graph is the predicted age and length frequency of sturgeon in Oneida Lake from the tagged sturgeon key. And once again, we have total length on the x-axis, the colors, which you can see the red, older colors much better in this graph, and frequency on the y-axis. And there's just been a shift in this graph where sturgeon of the same age as they are in the Genesee population appear to be longer. And then finally, since all the sturgeon caught in the Niagara River have been aged by agers, there are no unknown ages to predict per se. So this is just the age and length frequency of sturgeon in the Niagara River. And as you can see from this graph, there's not many small or younger fish caught at all, while many of the older fish are caught in a similar frequency to those predicted by in the Oneida graph. So to conclude, the sturgeon in the Genesee River appear to be younger and smaller, and this could be due to the gear used to catch sturgeon, or perhaps this is due to the more recent stocking program, but maybe there is actual variation between these populations. And the Niagara population, which is an extant population, and the stocked Oneida populations are looking quite similar, with the Oneida population even appearing to be larger at age 6. So this raises the question, could the Oneida sturgeon population be on their way to becoming a successfully restored population? So just for my main takeaways, in lake sturgeon populations especially, it is helpful to understand how these stock populations are performing. And these size and age comparisons are especially helpful for setting expectations in these populations that are not well studied. And finally, we need to understand that these populations are different if age-length keys are going to be made. And since I'm still working on this project as part of my honors thesis, I'm hoping to incorporate some Bonbert growth curves into this work, perhaps expanding this work to sturgeon populations in other New York water bodies, or maybe we can even tease out the true causes of these variations during the upcoming semester. So, thank you. I would like to especially thank Zoe and Stacy for all your help and mentorship this summer and throughout the semester. Thanks to the folks at USGS and U.S. Fish and Wildlife Service for providing data and answering all my questions. Thank you to my fellow CBS interns, and thank you to the Spindler Plum Travel Board for making this presentation possible.
Thanks, Krystal. Great, we have a few minutes for questions.